Hello, my name is Vincent Batts. I'm going to do a quick Buildah deep dive. This is going to be available and linked from a GitHub gist as well as this video on YouTube. They should be cross-linked and shared. Buildah, for those who are not familiar, is a container build tool. It is a direct invocation, like no daemon. It doesn't actually call back to like over a Unix socket to a daemon. Build tool targeting building OCI images. It supports Docker files as well as you could write a shell script that calls out to Buildah subcommands that looks very much like the syntax of a Docker file, since many people already admitted that Docker files look just like a derivative of shell scripts with different kinds of constraints. So in this overview, we are going to do three different approaches here. So first I'm going to check out the gist repo. So you can see that here as a Git repo. The Dockerfile is the first option that we're going to walk through. The build.sh is the next. It is going to mimic, it's a translation of this Docker file into a shell script, and the third is going to show you how to, like, in a way to make a minimal rootfs from outside of the container tool. So for that first Docker file, I'm using the example of the Golang base image. So many folks are used to packaging up some Golang binary and saying from Golang, go get this, go get that. Well, I've went and fetched the Docker file for that Golang binary, thanks to the effort of Tianan and others. The link to that original is in this gist, but I just wgetted it directly and committed it here for historical purposes. For this, we're actually going to push a few of these to a registry. For that, we'll just spin up a local registry instance. I managed to mung up my CNI network plugins. So I'm just going with the host for right now, and away we go. Buildah bud. This subcommand sounds cute and silly, but it's build using Dockerfile, and it's effectively synonymous or a drop-in replacement for Docker build -t whatever. So we'll call this one vbats Golang and build from our current context. So a few of the steps you'll see a little slightly decorated differently, actually like a monotonically increasing number for each instruction it's running in the Docker file. The other thing to notice there was that it was running as a limited user. So on newer kernels, and hopefully good features coming in 4.18 for supporting even more stuff in user namespace, the inside of the container runtime is running as effective root. Effective UID is 0, but it's user namespace, so it's actually running as a limited user and is just mapped UID GIDs. Yeah, here you can see it's done this under my home folder .local. Okay. So it has built this image now, and if I look at the images that are available, we just have the one that it was based on and the one that we just produced. Push, since we're going to that local host one, we'll tell it to not verify the TLS on it. Cool. So now we're pushing that OCI image out to a container registry so that others could fetch from it. So the interesting thing here is that it's done this build with a non-modified Dockerfile as a non-root user, not needing to call out to some other backend to get that done, and pushing it up such that it's just as usable. So you can see some of those examples already here. I snipped out some of the stuff in the middle, but that it pushed up, and you'll see the digests of those layers and objects as they're pushing up. So the blobs are actually like a tar archive and then pushing up the config, so it ends up with the digest of the image. Cool. So the next is going to be a build script, and so this build script is the a personal, like I just went through and hand adapted that same Dockerfile that we just did to build the Golang base image, redid it so it's such that it's a shell script. There's no particular benefit to this except for if you were some situation where you're migrating off to some other build infrastructure, where you have a build.sh in a repo, then it knows how to handle it, or knows how to set it up, and that it will, inside the container, will do whatever builds it needs to. Or like a make file target would probably be a good option. Make image, make push, something like that. But for the sake of example, here we have from some remote, and so now this from is our object that we are passing around to say Buildah run with this container instance, and with all the line escapes and everything, I found it easier just to do a inline, like an end of message for these chunks of shell script, setting some environment variables and so forth. Ended up finding something that could be improved, and had to make a workaround for setting variables that need to get expanded inside the container. But regardless, here's a working example. So again, as non-root, we will just call that same shell script we were just looking at. This is effectively doing exactly the same build all over again, but just to see parity of two different approaches that may or may not suit different use cases, to get the same output. think in this shell script I actually push it straight to the localhost registry as well. Since it's just a shell script, you don't have to commit and then push in a separate command. Yep. Super duper. So now we have our next build of that image. Again, run as a non-privileged user with an adaptation from a Dockerfile, but as a bash shell script. As it's finishing pushing that, this is largely as an example or maybe as a reference. The next example is a bit more of what the use case, like a more common use case would be for doing that kind of a build from a bash shell script. So one of the common questions that comes up pretty often in folks that start digging down into, okay, so where are all these base images coming from? And there's so many different container, or not even container, just file system build factories that might build RPMs, or they might compose RPMs or Debian packages. They might be using something like Octo Project for embedded to build minimal file systems, just enough to bootstrap. There is any number one of these image factories, but if you dig into where like the ultimate, like from Fedora or from Ubuntu are coming from, you often end up seeing something that looks like a Dockerfile that says from scratch add rootfs.targz, and it just extracts some already composed root file system straight into the image and then commits it as gospel. The challenge there is, where did that rootfs come from? And it varies wildly, and it usually varies on existing infrastructure that's already been around. So what we have done for the sake of this example is to have a simple shell script that's from scratch. Scratch, used to be just a 0-byte tar file, but at some point became like a magic word to just say there's nothing in this file system, just do a blank mount. So in this, we're going to produce the mount, the file path to that root directory wherever it is. So if you're like using overlayfs, you might see the ID of the path /merged or something like that. So then the interesting part about this approach is that it's a little less portable in that it relies on something about the host. If you're using Fedora, then you can use DNF, or Yum on CentOS, or apt on Debian and Ubuntu, and most of them have some kind of like install root. Pacman for Arch, they all do this. Slackware Slack package, you can do it like -- install root. So given whatever repo or local file package store, you do an install root. We're pointing the host's DNF at this container's mount directory. So from the Fedora 28 release, all I want to do is just install bash and core utils, and then we'll clean up that directory, because the DNF state with that install root, if we didn't do this clean step, even though the container file system doesn't even have DNF or RPM installed for that matter, it only has the extracted contents of bash and the extracted contents of core utils. If we didn't do this step, then you would see like var cache DNF blah from all the different repos that it pulled down. So then we'll unmount anything that's on our containers, our from scratch container, add a few configuration pieces to it, like set that by default it'll run bin bash and who it's created by and stuff like that. Commit it and push it. So let's change that to the red local. Super duper. Alright, so this one will not run as limited user currently. I'm sure there are some features or functions that you could do if you were using like a copy command to copy, say, a static binary or something into the containers file system. The DNF is the issue here because DNF running as a non-root user only does limited things. Installing is not one of those things. So we will say sudo build from scratch, and like I said, you're seeing repos here that are repos not in a default Fedora install, but these are on my laptop's install. So it's building up these caches into the containers file system because the host knows about the repos, but it now thinks in this fresh install root that it doesn't have any caches of those remote repos. Good gracious, he's 55 meg repo. Dead airspace. Make some noise. And so in these, you'll see a few things like it'll have the Fedora release information. It's like a base system Etsy pieces that various distributions expect to find these days. Locales, basic libraries, and done. There you see that directory that we're talking about, where it's cleaning that install root, removed all those big fat caches that we just saw, and that's it. Committing, pushing. So this is not altogether a minimal file system because it's got so much pieces that are not intended to be minimized, but as far as leveraging existing packages that are in a repo, just to say I only need bash or I only need core utils or whatever, that you can just say, install that minimal subset. This is not like a bunch of compiling from source and fetching from all over the place. You can leverage somebody else's dependency resolution and produce just a minimal subset container. The fun part is that you could then take this and run it somewhere else. And let's see here, sudo podman network host, because I bungled my CNI stuff. All right. It doesn't have that name, the remote name. Yep, so that's our stuff. So you can see here it's got built-ins, but doesn't have anything else. Pretty minimal. You find yourself in a sticky wicket at this point, because then you'd start to say, oh, I can't install anything. But if you're just dropping a binary into this, or what other boilerplate, you could figure it out. Anyhow, so that's the build rootfs example, and that is all. Thank you for listening.